Yesterday's lesson, we first started with talking about the basics of a function. To be a function, what test could you have used? Do you remember? Just vertical line test to test if it was a given function, because it was just the basic algebra 1. Every x needed to be unique. Then we got into the problems with the graphs, where they gave you an equation. They didn't give you a picture. They gave you an equation. And then given an equation, they asked you to graph the inverse of the equation you were good at. So these are answers for you to check. But how did we approach that? So Demetrius wasn't here yesterday. So he's gone home and he wants to figure out how to graph the inverse of, I think number 7 was negative x cubed, if I remember correctly. So I want to graph the inverse of negative x cubed. Tell them what you did first, somebody. What could you do first? Mary Jo? Perfect. So what she said was she made a chart of the given for the negative x cubed and got her values, and then she flip-flopped her x and y's, and then by transposing those, she now had the inverse. That's what she plotted. Those were her graphs. So checking your 7, 8, 9, 10, 11, 12. Is there anything I needed to chat about for anybody? And then the last group was all about invertible. To be invertible, both the given and the inverse need to be functions, right? So here's a general question. If I'd given you this number 12 and I said, I want to know if number 12 is invertible. Is it invertible, yes or no? No. It's not, even just from the very beginning. To be invertible, both the given and the inverse have to be functions. Is the given a function? No. So there's no way that it's invertible. Okay? Anybody end up with questions on that last group? I had to renumber everything because my answers included the 3 vocab words as numbers, so everything was off by 3. Anybody on this? Okay, so this was the basics so that we can build. And hopefully, again, with today's lesson, you're going to see a lot of repetition so that if you do it day by day, all these pieces are going to be really easy. On the calculator, and I'm connected so you can't grab it, but on the scientific calculators, guys, you know how to do square root and square. Most of you are really good at where that is. Right by the off button, if I remember correctly, is a key that says y to the x power or x to the y power, okay? Then on my calculator, in green right above it, because my second key is green, it says the yth root of x. It's taking the inverse of or the root of. So note that you've got that key on a scientific calculator. So if you, off the top of your head, you did not know what the cube root of 8 was, then and play with it ahead of time so you know how your calculator works, I would have to tell my calculator 3 for cube root. Then second, tell it what key it is, so do the button. Then type in the 8. Enter merges it all together to tell it that I want the cube root of 8. And anybody know what the cube root of 8 is? 2. And then my answer would be 2. Exactly. Okay. So if you are not amazing at your multiplication tables, then knowing how to use those keys would be really important come test day. Anybody on this before I go on? Okay. Okay, so today we're going to work with square roots, cube roots. We're even going to dive into a 4th root. All of those are under the umbrella radical functions. Something else we're going to do today is we're going to restrict the domain. That means we're going to talk about what x is allowed to be. Sometimes x can't be all real numbers. So that's where we're going to restrict the domain. So here we go. In your textbook, they give you this. They want me to take f of x equals x squared, and they would like me to find the inverse. Determine the inverse of the power function f of x equals x squared. So this is done for you. I'm going to do writing on it, but you don't, all you have to do is follow. It's already written down for you. Okay, so here comes the steps. If I want to find the inverse, first of all, anytime you see f of x, you want to rewrite it as y equals. So y equals x squared. That was their step one. Now, to do the inverse, what did we do with the table yesterday when we wanted to graph the inverse? We switched it, so guess what we're going to do today? Switch it on the equation. X for y and y for x. Still good. Okay, I want to get rid of the square. How do you get rid of a square? Square root is the inverse. Square root, square root. But then there was something maybe you learned in algebra. Don't forget your plus minus. And thus you end up with this. So with a visual, for you guys, they can't see it at home, but with my lovely parabola here, do you notice how I have a purple and a green? Okay? The right side of it is purple, the left side of it is green. Okay? So when I wanted to do the inverse, remind Demetrius what we did. How do I find the inverse with this? Rotate it 90 degrees, and then reflect it over the x-axis. Okay, so remember I started like this. Would you agree that making from your standard parabola, with the colors I have here, the purple side is the positive side, and the green side is the negative side. And then after I rotated it and reflected it, well, what part's on the top? Purple is the positive part above the x-axis, and the green is the negative below. That's this plus and minus, okay? The plus gives you a positive value. The minus is going to give you a negative value. The only time you will ever see those plus minuses is when you started with an even power, not with odds. So you'll never see it with an x cubed or x to the 5 or x to the 7, etc. Just when those guys are even, okay? Now, we'll be able to, in the next frame, restrict the domain, but questions there? Okay. So now, here is this lovely picture. The purple is the graph of y equals x squared that we've been graphing for quite some time. And then when I took it and rotated it 90 degrees and reflected it over the axis, I got the green. Or I took my table, and what did I do with it? Switched it, and I could actually plot the points to get the green as well. Could you tell me what 2 points both graphs have in common? The easiest by the table. 0, 0, and 1, 1. Very good. So sometimes they'll share common points. Could you tell me what their x-intercept is? 0, 0. What's the y-intercept? 0, 0, because we haven't moved it up, down, right, or left at all. All I did was do a little bit of rotating. Now, again, this was still with y equals positive and negative, both the top and the bottom arm of the square root of x. Okay, so then down here, do you see where this is saying from f of x equals x squared for values that are greater than or equal to 0? And look at the math symbolism for that. X is greater than or equal to 0. That's restricting the domain. It's saying the domain, the x, has to be a positive value. Well, doesn't that make sense for inside the radical anyway? Could you take in the set of reals, find me the square root of negative 3? No. My calculator would say what? Error, right? So we're restricting the domain by saying it has to be greater than or equal to 0. Square root of 0 is 0. You can do that. Square root of 1 is 1. Square root of 4 is 2, etc., etc. So this is restricting the domain, and we're going to get into that right now on this lovely chart. So if you fill in the first 2 charts with me, when we go to fill in the third chart, it's going to be cake, and then you will have a nice little piece of information to help you study, and it would be easy things for me to ask on a test. I don't have to ask all of it. All I have to do is say, here's this, give me the given y equals x squared. Could you please give me the domain of its inverse? Could you give me the range of its inverse? Things like that. So here we go. Is my domain on the given restricted? Yes or no? Yes, I highlighted it in that lovely aquish color. It says where x is greater than or equal to 0. Okay, so think of a parabola where x has to be only the positive side of it. Wouldn't it just be this arm? Okay, so let's make just a little sketch right here. So you're talking this. Okay, now, looking at that picture, we want to talk about the domain. What can you plug in for x there? What is the beginning number? 0. And then could you plug in 27, 32, a zillion? So your domain is from 0 to infinity. It's just this right arm. So what about my range? How low does it go? 0. And how high does it go? Infinity, yeah. So 0 to infinity. Where are these hitting the x and y axis? 0, 0. Because we didn't move it right, left, up, or down. Okay, that's the given. Now, keep this in mind, always, always, no matter what math class you're in. Once you have a restriction, it stays with the problem. So you see how I restricted the domain in the given. So back to my purple and green. So we only had the purple part of it, okay? And then when I go to do the inverse now, I'm going to rotate my nice parabola 90 degrees, reflect it over the x-axis, and can you see it's the positive, the top part of the sideways parabola? Can everybody see that? Okay, so we'll sketch it over here for them. So that's what I just did with the pipe cleaner. Now, talk to me about the domain. How low can it go? What is its smallest value? 0. And how big can it get? Infinity. Perfect. And these values won't always be the same, but they are here. We haven't done any moving of it. What about the range? It's still starting at 0, and it's going slowly up forever. And what about the intercepts? 0, 0. Question, because then we're going to do the same thing with the cube and the fourth. Anybody? Lovely. Anybody still writing? Okay. Okay, so now I want to talk about the cube family. So from y equals x cubed, the inverse would be the cube root of x. Can you take the cube root of a positive? Yes. Can you take a cube root of a negative? I see your heads going in different directions. Yes, you can. Okay, think about it. You know for cube root, that means 3 times of something. So isn't a negative times a negative times a negative a negative? So tell me what negative 2 times negative 2 times negative 2 gives you. Negative 8. So then the cube root of negative 8 must be negative 2. Okay? So when that index is odd, like a 3 or a 5, 7, you're allowed to take the root of a negative value. Okay? So up here, they gave me a lovely table already for x cubed. I don't want to have to put a lot of work into this. Tell me, given this table, what I could do to graph its inverse. Just flip-flop the x and y. You know that, right? Okay? So here's my lovely picture without me putting a lot of work into it. So I started with my standard cube. I took my standard cube, rotated it 90 degrees, and reflected it over the x-axis. And I got the one that looks more like a sideways one. Okay? Almost like a snake that's crawling in both directions. Okay, question there. Okay. Do they share any points in common? Yeah. Perfect. 1, 1, 0, 0, negative 1, negative 1. You can tell either by looking at the graph, or you can tell by noticing on your table, if both x and y have the same thing, then when you flip-flop it, x and y will still have the same values, right? So those are points that they shared. Now we're going to go from here. Is everybody okay with this? So can you see how the given is going to the right and left forever? I want you to hold this thought. It's going up and down forever. Does everybody see that? Okay? Look at the inverse one, the sideways one. Is it going to the right and left forever? Is it slowly going up and down forever? Yes. And where does it hit as far as on the x or y axis at? 0, 0. Okay. You'll see why I'm asking that in a sec. So now we need to fill in the characteristics of x cubed and the cube root of x. I just gave you the answers to all these. X cubed, what was the domain? What did it do? Did it go to the right and left forever? So what did we say that was? From where to where? Negative to positive infinity. And the range went up and down forever. Negative and positive infinity. And where did it hit the x and y axis? 0, 0. Awesome. Good so far. From the visual that I just had up there, now let's talk about the cube root of x. Didn't it go to the right and left forever? Slowly went up, slowly went down. The intercepts. 0, 0. Good. So we have already done a square root. We did a cube root. All of these are under the umbrella word radical functions, and that is what the entire chapter is, radical functions. Square roots, cube roots, fourth roots, sixth roots, any kind of root we need it to be. You'll see more of that when you take physics, for those of you that go on and take that, in the computer sciences, etc. But you will see a lot of radicals once you hit the heavier sciences. Questions so far with this? Okay, we're going to put it together in a minute with, once we know this, and then add in the fourth root. So hopefully you're taking good notes. Okay, so the chart's not made for you. This does not come in your textbook, but it's good putting the pieces together. The first one's talking about x squared. Does this have a restricted domain? Yes or no? Yes. What is it saying? Greater than 0. Okay, did we just do this? Wasn't this 2 charts ago? Okay, so for x squared with a restricted domain, it was just this arm, remember, going up. Tell me what my domain was. We just filled it in without looking. Say it louder. 0 to infinity, and so was the range, and they already filled in the x and y intercepts for us. Okay? Then we took this right arm of mine, and we reflected it, we rotated it 90 degrees and reflected it over the x-axis. That was the purple one that I held up before. And you had something that ended up looking like this. So now with my new look, could somebody tell me what my domain was on that problem? Same thing, 0 to infinity, and so was the range, and neither the x or y intercept changed. Okay, so we just did that. Next, of course your eyes have to be open to see some of this. X cubed, x cubed. So this was x cubed, no restrictions. What was your domain and range? Negative to positive infinity, or all real numbers. And where did it hit as far as an axis? I would like to hear a guy voice this time. 0, 0. Good. Okay. Then we had my normal cube that was rotated 90 degrees and reflected over the x-axis. So it looked like the sideways swiggle. What was your domain and range? Good. So I wanted it, are you to the point where you're like bored of it? You're like, Mrs. Stewart, we know. That's what I want. Okay, so now, x to the 4. Is the domain restricted on this one? Yeah. Yes. So what is it telling me I can use? Only positives. Good. And once they've restricted the domain, it stays with the problem. That means when I go to do the fourth root of x, am I allowed to put a negative inside the radical? No. Very good. Okay. So with my prior knowledge, x to the 4 is a relative of x squared, so it looks like this again, doesn't it? But it only wants the positive part, so am I green, purple, or both? Just the purple part. Very good. Okay, so tell me what you know the domain has to be. 0 to infinity. Do you see a pattern? And then when we took that and rotated it 90 degrees and reflected it over the x-axis, 0 to infinity again. It was the top half. Looks like the picture that I drew up there for the square root, just a bit wider. Question. Okay, now we're going to put it together with some word problems. Question? No. Okay. So be able to do any of these. These are nice questions. Nothing has been shifted yet. We'll do a problem or two where we shift something, and then with the new shift, make sure that we understand, again, the domain and the range and the x and y intercepts. Okay? So here we go. Skills, practice. So I chose some right here. They're great test questions, all of these. So take good notes, please, in your skills practice. And if you chose to forget it, then write it down on a piece of scrap paper. I want all of you to be great at this on the test. So first off, I need somebody who decided they're going to be nice and volunteer for me. Who's going to read aloud? Don't all volunteer at once. Tyler. Please. Okay, so they want me to take the given equation and write it in terms of distance. So this is like a part A, B on a test. First, take the given equation, write it in terms of distance. Part B, now that I give you these numbers, find the answer, solve it, okay? So given this t equals square root of 2d over g, they want us first to solve for d. Tell me what you could do. Look where d is. It's inside the radical. So I need to square both sides. Awesome. So we're going to square both sides. Let's see if it lets me change colors. And we're going to square both sides. And now we have t squared equals 2d over g. And some of you might even see it as t squared over 1 if you're a proportion kind of person. I want to get to the d. Tell me what to do next. Multiply by g or cross multiply. It's both the same thing. So g t squared is 2d. Almost there. Divide by 2. Perfect. And we are done. We isolated. We solved for d. Okay, that's your algebra. You know how to do that. The new part is undoing the radicals. Okay, now, part B is they're giving us some numbers to plug in. 9.81 meters per second squared as the force of gravity. So guess that goes in for g. Okay, so we're going to replace g with 9.81 times, calculate the distance of an object that will fall in 3 seconds. Seconds is time. So 3 squared over 2, and then I'll leave it for you to do the math. If I didn't have a calculator that knew orders of operation, I would square the 3 times 9.81 and then divide by 2, enter. Question on that? Amazing. Lovely. Okay. We've got another one. Brianna, have you read for me? Wait. I'm doing 36. Sorry. So we want to write the equation of the side length, and then they gave me information, and then it continues, calculate the volume, write the equation of the side length as a function in terms of the volume. So we want to write our information in terms of the volume so that it says V equals everything else. That's where I'm going. And then over here, when there's a little 3 there, if you have to ever read it, or if they give it to you like without a formula, actually in words, when there's a 3 there, you're going to read it as cube root. If there's a 4 there in the index, you would say 4th root, etc. Okay? So now, step 1, from S equals cube root of 3V. I want to get this to say V equals. Help me. What would you do first? Cube it. Awesome. So let's do that first. Let's cube both sides. So we'll put a cube here and a cube here. So now you have S cubed equals, these guys are inverses, so they delete. Almost there. What else would you do? Divide by 3. So volume is side cubed, then divide by 3. That's what it's saying. Question there. Okay, now, next part, calculate the volume of a pyramid with a side length of 4.2. Is it ready to just plug in? So volume equals 4.2 cubed, enter, divided by 3, enter, and then you would get your answer. Anybody not good? Yes, exactly. Okay, the next, anybody not good with this one before I go on? Anybody still writing? Okay, so on the next group of problems here, instead of them just giving me like square root of x that we just filled in on our chart, they want the characteristics again, but tell me what I just did on number 15 with the square root of x. What are you doing with it? What's that plus 1 tell you to do? You know this. Move it up 1. So you knew that the square root of x, isn't this, oh, what's taken for granted in front of the radical here? Okay, so the index is a 2, and then is this a positive square root of x, a negative square root of x, or both? Just positive. If they wanted it to be both, they would put a plus minus. If they wanted it to be a negative, they'd put a negative. So since there's no sign there, isn't that what you usually do when there's no sign, it's taken for granted, it's a positive. Okay, so I took my positive square root of x, and I'm moving it up 1 unit. Is that what you're visualizing? Shake your head. Okay, now, do you agree that I could still plug in 0 into the radical for x? I could plug in 1, 2, 3, 4, zillion, etc. Could you plug in a negative? No. That's why your domain goes from 0 to infinity. Notice my range is different from on the chart because I took my parabola, my sideways parabola, and I moved it up 1. So what is the lowest point right here? How low does it go? 1, right? So its minimum is 1, and it goes on to infinity. X-intercept is not 0, 0, is it? Where does this picture that I just drew you hit the x-axis? It doesn't, so that's why there's none. And then last in that group, y-intercept. Y-intercept. What is y-intercept? 0, 1, because, isn't that the point there? 0, 1. Okay, now they want me to do the same thing with the cube root of negative 2x. So what I need to picture there is that it is an inverse. So my cube that's been rotated 90 degrees reflected over the axis. Can you plug in, this is a cube root, can you plug in a positive into the radical? Yes or no? Cube root. Look at your chart. Yes. Can you plug a negative into the radical? Yes. Okay? So for my domain, can I still plug in anything I want? And is it still going to slowly go up and down forever? So your domain and range are still going to be your all real numbers or negative to positive infinity. It has not shifted up like number 15 did, or down, or anything like that. So my intercepts have not changed. the value, that -2 that you actually see inside the radical, back to the A, B, C, D that I'll write on the backboard again. I had to take it down for the exam, but from all our transformations from first semester, that would just be the B value, which is your horizontal stretch and compress. That's all that's doing. Okay, last one. Number 32. Who's going to read for me? Trey.
The relationship between the radius of a circle and its area is given by the equation r is equal to the square root of a over pi, where a represents the area of the circle. Right here, we have the radius of the circle, the area of 50.24 square meters.
Okay, so in this problem, they're asking me to do a couple things. I am actually going to find r, which is the equation's in the form to find r. But they asked you to do something else. They also asked you to write the equation as the function of the area. So they're asking you to solve it for a, but then that form actually is not any prettier than the way it is as far as solving, but I'm going to show it to you the way they did it. Okay, so if I want to take my r equals square root of a over pi. I want to solve for a. Help me. What would you do first? Very good. So we're going to square both sides. Almost there. Say it again. Multiply by pi. Oh. Do we know that? Okay. So we've got a equals pi r squared. Next, they want you to find the radius given the area. So where would you put the 50.24? In for the a. So if I did it the way they had just had me set this up, like it worked nice on all the others, I'd actually have to totally undo this in order to get the answer. If I go to the original equation, and I don't know if this was intentional on their part or not, they said use this, and then you could do the math and answer the question. Okay? So please, please practice these so you get great at them. I definitely put word problems on the test. Look at the study guide that you all have so you can see where I'm heading, what's left, so that you can do amazing on your test next week. Test chapter 9 is Friday the 19th, a week from Friday. Okay? And so we've done 9-2. We still have 9-3, 9-4, 9-5, 9-6 to go. But again, if you're doing with me day by day, it won't get any harder as long as you just keep working with me. Okay? Great job as always.